Good afternoon to all. So how many of you feel thirsty right now?
Yes, sir.
Yeah. Okay. So once you feel thirsty, what do you tend to do?
Sir, I'll be tending to drink water.
Very good. Superb. So you'll be having the tendency to take more and more of water. But have you ever thought about how do you take this? How this sensation of thirst facilitates you to take water?
No, sir.
No. Right? So that's what we are going to see in today's class. That's the importance of today's class. So we are going to see about one of the important centers. That is what we call it as the thirst center. Right? So at the end of today's class, you will be knowing about the location of the thirst center and the stimulus. That is normally what is the stimulus for a thirst sensation and what are all the receptors for this thirst sensation, and finally you will be seeing what is the thirst response as such. Right? So mainly the thirst center is the one which brings about this thirst sensation and also it facilitates you to take up more and more of water. So how is this being produced? That's what we are going to see in today's class, right? Yeah. So where is the thirst center being located, right? So it's mainly in the pre-optic area of the hypothalamus. So last class we saw that there is something called feeding center. It is being located in the, it's in the lateral hypothalamus. Very good. So this is mainly in the pre-optic area of the hypothalamus. Fine. So this is where you can see that these are all the nuclei of hypothalamus. Last class we have been discussing about all the nuclei, and in that this is the most important center, that is the pre-optic area, which is mainly the thirst center. So just above the pituitary we have all the hypothalamic nuclei. In that we have the pre-optic area. So now what is the stimuli for the thirst sensation? So when do you tend to have more and more of thirst sensation, right? So it's because of increased osmolality of the ECF. So what is the normal osmolality? Normal plasma osmolality?
290 to 300.
Very good. It is around 290 to 300 milliosmoles per liter. So once the osmolality increases in your body, obviously that is where you feel the thirst sensation. So the reasons for the thirst sensation being produced are increased osmolality being due to either dehydration. In that dehydration, obviously water is lost and compared to the water is lost more when compared to the solute level. So that is where you have increased osmolality. And the other thing is when you have excess salt ingestion. So these are the two reasons where we have a increased osmolality. Fine. So other stimuli for thirst are, so whenever there is a decreased plasma volume, that's what we saw in dehydration. Obviously whenever there is a decreased plasma volume also, that will cause the thirst center to get stimulated. And the next one is whenever there is an increased angiotensin II formation. You all know about the renin-angiotensin system, and in that the increased angiotensin II will always cause the thirst center to get stimulated, right? And the next one is all about the dryness of the mouth. So whenever we feel dry mouth or obviously saliva is decreased production, obviously we tend to have more and more of water. So that is also another stimuli for the thirst sensation, right? So now, what are all the receptors? As we see, normally the receptors for the thirst sensation is all we call it as osmoreceptors. Okay, because whenever we say osmolality, it's being always sensed by the receptor called as osmoreceptors. When we say pressure, it's all about the baroreceptors. Whereas when we say chemicals, it's always about chemoreceptors. So here it is all about osmoreceptors. And the next thing is, where are these osmoreceptors located, right? So normally we say these osmoreceptors are located outside the blood-brain barrier. So last class itself we have seen about the blood-brain barrier, everything, right? So here it is always situated outside the blood-brain barrier. That means it is directly exposed to the plasma osmolality. So obviously these are the osmoreceptors which are present outside the blood-brain barrier. And where are they situated? They are mainly situated all around the ventricles. So we know the third ventricle, lateral ventricle, fourth ventricle, right? So surrounding these ventricles are present these osmoreceptors. That's why we call them as circumventricular organs, because around the ventricles these are present, right? So what are all these circumventricular organs? This is a very important Viva question and it should be remembered always. Fine. So I always give a mnemonic for this circumventricular organs. You can just see here. Okay. So the mnemonic or the easy mnemonic here will be SOAP. S-O-A-P. So S stands for the subfornical organ, right? And O stands for organovasculosum of the lamina terminalis. And A stands for area postrema. And the last one, P stands for posterior pituitary. So this should always be remembered. So what is the mnemonic? So very good, right? S stands for subfornical organ, O stands for organovasculosum of lamina terminalis, A stands for area postrema, and the next one is P stands for posterior pituitary. So these are all about the receptors. Very good, right? So we'll go on to the next one. So how is this thirst response being produced? So we have seen about the location of the thirst center, the stimuli for the thirst sensation and the receptors for the thirst sensation. So the last one will be how is this thirst response as a whole being produced. Fine. So this is what we can see that normally the osmoreceptors are getting stimulated by what is the major stimulus I told you? Increased plasma osmolality. So whenever there is increased solute concentration, that is what is going to go and stimulate the osmoreceptors. So through these osmoreceptors is what your thirst center getting stimulated. So there is also another mechanism by which the ADH or the antidiuretic hormone is being stimulated by the same osmoreceptors, but that we are not going to discuss as of now. Fine. We are mainly concentrating on the thirst center as such, right? So plasma osmolality causing primary osmoreceptors to get stimulated, which will stimulate the thirst center, right? So the next one. So how is this whole mechanism being produced, or that's what we call it as the thirst response. So what are all the stimuli I told you already? So when we see here increased plasma osmolality, obviously that will stimulate what? Mainly the osmoreceptors, that will stimulate the hypothalamic thirst center as such. And the next stimulus is whenever there is increased plasma osmolality, obviously saliva will also be decreased. So it will cause a dry mouth. So that will also stimulate your hypothalamic thirst center. And what is the other stimulus I told you? There is a decreased plasma volume. So whenever there is decreased plasma volume, that will cause a decreased blood pressure. That will cause the renin-angiotensin system to get activated. So whenever there is a renin-angiotensin system getting activated, what is formed more? More of angiotensin 2. So this is also one of the stimulus for what? Your thirst sensation, right? So all these three mechanisms will go and stimulate the hypothalamic thirst center. So whenever the thirst center is getting stimulated, obviously what do? As you already told me, you tend to take more and more of water, right? So when the water is taken, it is mainly going into the GI tract and then it is being absorbed from there, right? So finally, whenever there is more and more of water going into the blood, obviously what will it do to the plasma osmolality? It will decrease it. So we started with increased plasma osmolality, whereas it has ended with decreased plasma osmolality. So what kind of feedback mechanism it is?
Negative feedback.
Very good. It's a kind of negative feedback mechanism. How does your body always tolerate or obviously change it towards that negative feedback mechanism? Very good. Right. So the summary of today's class is, what is the location of the thirst center? It is in the preoptic area of the hypothalamus. Very good. The major stimulus for thirst sensation is increased plasma osmolality. And what are the receptors for thirst sensation called? Osmoreceptors. So what is the mnemonic I told you for that? So very good. Okay. Yes, all these things you know. You should always read it, right? And the last one is thirst response. How is it being produced? Fine. Any doubts in this?
No.
Very good. Right. Thank you. So we'll see the other functions of hypothalamus in the next class. Thank you very much.